All right, we've got a question here about this particular series and whether or not it converges or diverges. So I thought we'd take a look at it. Right now we've got the sum from n equal 1 to infinity, 10 to the n over negative 8 to the n minus 1. So what we're going to do is we're going to see if we can convert this into something that's recognizable. So one thing we do know a little bit about is how convergence of geometric series go. So is there a way that we can maybe get this to look like a geometric series? So let's start with this. So suppose we have this expression. Notice we have the nth power in the numerator and n minus first in the denominator. If we want to get a common ratio, we kind of need to have those powers be the same. So what I'm going to do, I'm going to pull one of these 10s out front, and that leaves me 10 to the 1 less power, so that makes it n minus 1, over negative 8, also to the n minus 1. Now I've got the powers the same. Now that's going to be handy because we're starting to look at something that looks like the a out in front in a geometric series. Remember, they're a times r to the n. So we're starting to get things that look similarly. Here I've got an n minus 1, but it really doesn't matter what happens at the very beginning of a series. What determines its convergence is what happens on the tail end, because the first so many terms, if you add them up, you can actually get a number, right? So it really, what determines whether it diverges to infinity or not is what happens from a certain point on. So what I would like to do is get this to look like what we're used to seeing with the geometric series. So what I'm going to do is I'm going to say, well, I can change the indices. When n is 1, I get 1 minus 1 is 0, 1 minus 1 is 0. So I basically get the power of 0 for each of these guys. So what I can do is I can change it so that n starts at 0, and then put 10 times 10 to the n over negative 8 to the n, because I end up with the same thing. If I start at 1 here, I'm starting at zeros for the powers. Here I'm starting at 0, and therefore the zeros are the powers. And again, I'm going to infinity, so it really doesn't matter how I write the indices. But now it looks like what we're used to seeing almost for a geometric series. Oh, would you like to finish it up? Go right ahead. Thanks so much. I'd be happy to. What we really want to do next is to try to get this into the quote common ratio form. So what I'm going to do is I'm going to take this guy, since both of these are to the same power, I can then say we could write this as the sum from n equals 0 to infinity, 10 times 10 over negative 8, the whole thing to the n, because I had n in the numerator and n in the denominator, so now I can actually just combine them into 1. Now it's starting to look like our common ratio. So here, the common ratio is r equal 10 over negative 8, or negative 5/4 if we want. And then we can use what we know from geometric series and convergence. We know that a geometric series, if the absolute value of the ratio is smaller than 1, it converges. Otherwise, it's going to diverge. Okay, so in this case, we have the absolute value of negative 5/4 is 5/4, which is clearly greater than 1. So this series is going to diverge. Okay, so now we don't have to worry about finding any value to which it's converging or anything, because we already know this thing is going to take off to infinity, because my ratio is greater than 1. So, hope you found this helpful, and if you have any other questions, I'd be happy to try to answer them. If not, energize.